So this is the copper chloride solution. There you can see the color. Fresh solution. Take note of the color. Take note also of the color of the electrodes. So there we go. You can see the red is the positive electrode and the black being the negative. You can see it runs back to the power source, and we're going to put it in and turn the power on, and immediately you can see bubbles forming at the positive electrode. As the reaction starts, I'll leave it running for a few seconds before we pull it out and look at the negative electrode. Okay, we've been running long enough now. Just the start of the reaction again. It's just been running like 2 minutes. And there we go. You can see, just trying to get a good angle, you can see all the copper that's starting to be deposited on the electrode. Again, the solution is still pretty fresh, but we're already pulling copper out of the solution. Okay, so that is a fresh solution. Okay guys, so this is a fresh copper chloride solution that we've just started with one of my grade 8 classes. It's been running for about 10 minutes. Take note of the blue color there. Then I just want to trace the red electrode lead here. If I hold it in my hand and we follow it, you can see that is the positive terminal. And then the black electrode lead, there we go, there you can see that is the negative terminal. And then if we follow the lead up, there, that's the negative terminal. So now you know on the left of the screen is the positive terminal, and just look, so left of screen is positive, right? So look at which electrode is giving off bubbles. So that's the one on the left, which is the positive electrode. Then the one on the right, I'll lift it out now so that you can see very clearly there already. After only 10 minutes, it is coated in copper, that nice reddish brown color, and that is on the black electrode, which is our negative electrode. So the copper metal is going to the negative electrode, and the chlorine gas is being released from the positive electrode. So you need to understand the reasons why. I'm going to leave this running for a little while, and we're going to look at the change in color over time. Right, so it's end of day 1 now. Reaction's been running for about 3 hours. I wouldn't say you can really see any obvious color change. The insulating, this thing is rubber at the top with the 2 terminals you can see are placed in it. That thing is rubber. It's getting quite warm with the current passing through it. And then there you can see, if I just change the angle a little bit, you can see just how much copper is deposited onto the electrode, and you can also see it's starting to drip copper into the bottom there. And you can see the reaction is continuing. You can see it's still giving bubbles off. If I get it from a better angle, there you go. So still getting bubbles off, not too much color change. I'll have to turn it off because I can't leave it here unmonitored. So I'm off to sports practice now, and you can see when I turned it off there, the bubbles stopped. So lights off, no more bubbles, no more reaction. I'll come back tomorrow and turn it on again, and we'll do some more time lapse. Right, so we are on day 2. We are more or less halfway through day 2. You can see I actually had to switch it off earlier today while I was teaching. My grade 10s drew my attention to the fact that the solution was running almost clear. Now if I focus in on the solution, you can see compared to yesterday that it is bright blue, and you saw there that I flicked the switch. Okay, if I try and focus in on the terminal that's got the positive terminal that's on the left with the red lead going to it, you can see the rate of bubbling is much less than it was yesterday, and you can see just how much copper has been pulled out of the solution. I don't want to unsettle it. I'm going to pull it out at the end. You can see it even falling off there. So you can see there's lots of reddish brown copper in the solution. You can see how much of it there is. That's all been pulled out of the solution. You can see the solution itself. If I come away, you can see it is still light blue, but it is much, much lighter than it was. So we're pulling all of those copper ions out of solution. I've had boys during the day complaining, "Oh sir, but the classroom smells of chlorine," because of all the chlorine gas that's been given off. So we're pulling all of that out of the solution. As a result of that, the solution is going clear, and we will be left eventually with water in the beaker and a lot of copper left behind, as you can see. So I'm going to leave it running now. There you can see it's on. You can see the reaction is continuing. You can see there are bubbles relatively slowly, but I just did want to catch it while it was still light blue, and I'm going to leave it running, and we'll have a look at it in a little while and see how the color changes even more. Okay, then here side by side we've got a live time lapse, because on the right is the reaction I started with the previous class. That reaction's probably been running for about 5 or 6 hours total. You can see the solution is very, very light blue. Lots of copper deposited on the electrode there on the right hand side. It's not hooked up at the moment. But you can see that was the negative electrode, and I am going to hook it up again, and we're going to continue that reaction. On the left of the screen I've got the fresh reaction that I have just started with my second class. You can see the bubbles being given off. You can see the electrode is coated in copper, and you can see the very stark difference in color, because in this solution there are still lots of copper ions in solution, so it gives the rich blue color. In this one we've pulled all the copper out of the solution, and therefore the blue color is starting to be lost and it starts to go clear. So I'm now going to just change the leads over back to the solution on the right, and we're going to continue the solution on the right, and once the reaction's finished we'll compare the colors again. Okay, so here I've just changed the leads over again onto the solution that's been running for a little bit, and again you can still see the nice solution, and the bubbles are now being given off at a much slower rate though, because there's not as much chemistry available to react, so the reaction is much slower, but you can see the reaction is continuing in that beaker. Just give it a chance to focus. And we'll continue to leave it to run for the rest of the school day today. I'm going to leave that one unreacted so that we can compare colors. And I'll continue to run the solution in this solution on the right. I'll continue to react it and see how clear we can get it. Okay guys, so we're back. It's now day 3. Remember that's school days, it's not an entire day, so I can run it for about 5 hours during the day. So it's probably been running for about 10 hours. You can see I've just turned it on, right? So the power is on, the current is running. You can see on the positive terminal there, so look, the red lead, that is the positive terminal. You can see the positive terminal has still got bubbles forming, that is chlorine gas, but the rate of the reaction is very slow. The reason for that is that there are very few ions left in the solution. Look at the color, you can see the other one with the fresh solution is sitting next to it. So the real indication of how few ions are available is the blue color. The lighter the blue, the fewer copper ions there are available. And you can see that the solution on the right is almost clear. You can see all the copper that has clumped up on the negative electrode, right? The black lead goes to the negative electrode, and you can see all that copper that is clumped up around the negative electrode. So most of the copper that was in the solution, so in this beaker here, the copper is still in solution, most of it, okay? Although I did run the reaction for a little bit, so we do have a slight coating there. but really most of the copper in this beaker now is now being drawn out of solution. So we have decomposed the copper chloride. So that is the compound. It's actually, the correct name is copper 2 chloride. So for those of you that might be watching this and you've finished grade 9, the chemistry in grade 9, or you're maybe grade 10 and above, you will know what why we give it that name. But the copper 2 chloride, or if you're only in grade 8, you can just call it copper chloride. But that has been decomposed and broken down, and we're giving off the diatomic element chlorine at the positive electrode, and we have the element copper being deposited at the negative electrode. So we'll just leave that running for a little while longer. It's not going to take much longer before the reaction is finished, and we'll have another look at the color then. Right, just wanted to take a quick clip here. We about 13 hours in, and look how the rate of the reaction has slowed. You can see how slowly the bubbles are being given off. We do still have a slight blue tinge, so there are still some ions available for the reaction, but very, very slow now. Right, it's time to finish off. So I want you to just see here the power is off, and I'm going to flick the power on, power's off, right? So nice and close up. I'm focusing on the positive electrode on this side. Oof, maybe I need to take the camera away a little. You can see there's no bubbles. Now I'm just going to flick it on. Give it a chance to focus. And there are still no bubbles. If you just watch it for a few seconds, there are still no bubbles. Look at the color of the solution. You can see if I shine right through it, it's completely clear. If I come around this side, you can see there is lots and lots and lots of copper. The reason that it's spreading out is, remember that charge, although the electrode is charged, the charge can travel through the metal because the metal is conductive. So even the metal that's deposited on the bottom there, when the current was running, it would have been attracted to the ions in solution would have been attracted to that metal because of the charge, and the electrons would have been able to conduct all the way through the metal and reach the electrode to allow electricity to flow through the circuit. Okay, so there we go. We've finished the decomposition reaction, and there's the two solutions in shot, right? What we started with, nice and lovely clear blue, lots of copper ions in solution. You can't see that they're there, but there's also lots of chloride ions in that solution. And then after probably about 13 hours, maybe 13 and a half hours of trying to run current, now we are trying to run current through it, because there's no longer any electrolytes present in the solution, so the solution will no longer conduct electricity. When it's blue like that, the ions are able to conduct the electricity. So that's why we've not got any current flowing now, whereas if I did hook that one up, it would have current flowing, but you can see there are no leads attracted. Just a reminder again, the red lead, that is your positive terminal, so that attracts the negatively charged chlorine ions. And then your black lead, there you can see it there, that is the negative terminal, and that is attached there. So that negative terminal attracts the positive copper ions. Remember, copper is a metal, so it wants to get rid of its valence electrons. Electrons are negatively charged, so when it gets rid of the negative charge, it ends up as being positive. And then when those ions get to those terminals, the chlorine gives its electron away. That electron is then able to flow around the circuit. That's what electricity is. It's a flow of electrons through a circuit. And then it goes all the way around the circuit to the other terminal, and the copper gains those electrons and then becomes an element again. I can tell you now it doesn't smell of chlorine anymore like it did earlier, obviously, because there are no bubbles being given off. And you can see all the copper that we have managed to purify and pull out of solution during our decomposition reaction. Okay, so there you go, visualized a full and complete decomposition reaction, starting with a compound which was soluble in water, and where, because it is an ionic compound, the two elements that make up the compound, they get split apart by the water molecules and form electrolytes. Those electrolytes then have a charge as ions and are able to move around in the water, and the solution is therefore able to conduct electricity. And that's what we've done here, is we've made the solution a part of the electric circuit, and we've used the process of electrolysis to complete our decomposition reaction. And now that I'm finished here, let's just pull this out and just look at how much copper there is. You can see some of it just falls off, but look at how much copper there is on that electrode. Lots and lots of it, and you can see there's even a whole lot sitting there in the bottom of the beaker that's fallen off. So that's just how much copper we have purified out of the solution, and obviously you can't see the chlorine gas because it's been given off into the atmosphere.